right, D-1, multiplication properties. My notes take up about a page, but mine are almost exactly a page, so yours might be a little over, and that's okay. All right, first thing we're going to do is identify what is a power. Okay, so for a power is what we call that whole thing, 2 to the 5th power. So there's two ways we can say that. We can say 2 to the 5th power, or we could say 2 to the power of 5. And in this power, there's two parts that are really important. We need to know what is the base and what is the exponent. This is just review at this point, just to make sure we all have the same vocabulary. So which part is the base? 2. And which part is the exponent? 5. So when we talk about 2 to the 5th, that whole thing is called a power. If I say exponent, I'm talking specifically about the 5. And what does 2 to the 5th power tell us to do? Good, we're going to multiply the base. The 2 is the what, and then the exponent is how many times. So we're going to do 2, 5 2s. So 1, 2, 3, 4, 5. All right. What about x to the 3rd power? Because that's what we're going to be dealing with mostly today is going to be variables. Variable bases. So in this case, we want our base and our exponent. What is the base of x to the 3rd power? Good, x. What is the exponent? 3. But I want to know, what does that mean? What does x to the 3rd mean? X times x times x. We're going to learn 3 properties today, but we're really going to just break it up into 2 properties, because 2 of the properties are kind of like the same thing. So we're going to be like, nah, same thing. Okay, before we do the properties, we're going to work it out to kind of figure out the pattern. A property is just another word for a rule. So when we have multiplication properties, we're really talking about multiplication rules. Okay, so if you want to write rules there, you could. Okay, so for number 1, we're going to have x to the 3rd power times x to the 5th power. This is where I'm going to use my highlighters. So if you want highlighters, remember that's okay. They're in your tubs. So let's talk about what that means. X to the 3rd power times x to the 5th power. What does x to the 3rd power mean? Yeah, we're going to have 3 x's. X times x times x. So that's the x to the 3rd power. So I'm going to put that yellow because that's where I got that from. It was from the x to the 3rd. And then I'm going to multiply that by x to the 5th power. How many x's are there in x to the 5th? 5. 1, 2, 3, 4, 5. look at this though. Between the yellow and the pink, or between the yellow and the orange, or whatever colors you use. The government says so. All right. How many x's are we actually multiplying? 8. How did you get 8? 5 plus 3. Did anyone count it out? 1, 2, 3, 4, 5, 6, 7, 8? No? Okay, well, I did. Thanks. Okay, there's really 8 x's altogether. So because the base is the same, we can write it as an exponent. What is the base going to be? X. And what is the exponent going to be? 8. So we're going to write that equals x to the 8th. For that problem, yeah. I mean, that's the start. What? Yep, for that one to start. All right, so this brings us to our first rule. Our first rule is the product of powers property. Product of powers property.
When you see that word product, what do you think of in math? As answer to a multiplication.
Good. So we're going to look at this product of powers property. When we see something that looks like m to a power of a times, and then we have the same base. So I'm going to repeat that m, and then maybe I have a different exponent, so I'm going to use b.
Remember, for multiplication, we use that little dot. So that little dot you see there in the middle, that's actually how we write multiplication usually in this class.
A. M to the a times m to the b. And what this tells us is if we are multiplying powers, with the same base, so we have an m and an m, or in example 1 we had an x and an x. They have that same base. What are we going to do with those exponents? How did we get 8? Yeah, we add them. So that's what our product of powers property tells us, is that we don't have to write it out every time. Okay, if I said x to the 20th times x to the 42nd, would you want to write 20 x's and then 42 x's? No. We want to use this rule to kind of skip ahead and see what our final answer is. You can. That's kind of what I like about this chapter, is you can write it all out. It's probably not the best choice, but you're able to do that. That's one of the strategies. So let's use that property. On number 2, if I have x to the 5th power, y to the 3rd power, times, so again we're going to use that little dot for times, x to the 6th power, y to the 5th power. The big idea with our product of powers is they have to have the same base. So which powers here have the same variable base? The x's, and what other ones have the same base? the y's. So remember when this x and y are touching each other, what does that really mean we're doing with them? Multiplication. So really we're just multiplying everything. And with multiplication, we can use our commutative property. Remember, commutative means what? Not combine. Flip it? Yeah, like move it around. Commutative. It's like commuting to work. You can move them around. So we're going to move them around so our x's are together and then our y's are together. So I'm going to write this as x to the 5th power times x to the 6th power times y to the 3rd power times y to the 5th power. Now this part you probably aren't going to need to write that down every time. You might, but you probably don't need to. You might be doing this part in your head. It's good for our notes though to write it down. So that way when we get to harder problems, you can look back and be like, oh yeah, that's what we were thinking.
How do we know that we could say that x times that x and that y times that y? Because in our first example, I only see multiply one time. I see one dot. But when we moved it down, I see it 3 times. Put it in between. How do you know? So the one in the middle tells me that I'm going to multiply each one. Awesome. They're right next to each other, and remember when there's nothing else there, that tells us we're multiplying. And we practiced that a little when we were solving for variables, right? And that it would be like 4x. And we knew to undo that we had to divide those.
Alright, so with x to the 5th times x to the 6th, we could write out, just like we did in number 1, we could write out the number of x's and the number of x's and figure it out. Or we can kind of visualize that. If I have 5 x's and then 6 more, how many x's total will we end up with? 11. How did you get 11? So for my pink, I did 5 plus 6 equals 11. Again, when you're doing your work, you probably wouldn't need to write that down, but because it's our notes, we're just writing down our steps. How many y's would we end up with? How did you get 8? Good, we have 3 y's, and then we have 5 y's. So 3 plus 5 equals 8. And that was for my y's, which I did yellow. Can I combine my x's and my y's together? No. So this is my final answer. That's as simple as I can make it. Say it again. I personally wouldn't. You could. It's not wrong if you do. I guess it's just implied that it's there.
Another way to write multiply is to snip them together. So if you put the little dot there, then you find 2.
Yep. Alright, I'm going to put a line through because now we're going to go to the next kind of idea. So that was one of our rules. I'm going to move on to our other rule we're dealing with today. And really it's 2 rules, but they're like the same thing. Okay, like when your parents are like clean your room and then they're like put your laundry away, really it's like the same thing, right? Like tidy up. Okay. So for number 3, we're going to show this again by writing it all out. We aren't going to just skip to our answer. We're going to actually show how to get our answer. But then eventually we're going to do it without showing every step. So in number 3, we're going to have in parentheses, so the quantity of m to the 3rd power, and then on the outside of the parentheses is to the 2nd power. So we have 2 exponents, 2 powers. So what does this squared mean? It's an exponent. It's 2. What are we going to have 2 times? M to the third. That's on the inside. So this is going to be broken up into m to the third times another m to the third. We have that m to the third 2 times. How many m's is this m to the third? 3. So I could write that as m times m times m. How many m's is this m to the third? 3. How many m's total do we end up with? Good. So Melody noticed that we take the exponent on the inside of the parentheses and we multiply it by outside. 3 times 2 is 6. Because we have 3 how many times? 2 times. That's what times mean, is that we're doing 3 and 3. We have it 2 times. So together that would make 6. Let's try one more example before we go on to our rule.
If it would help you before we do that. Okay, never mind.
No, you're good.
I was going to say let's write some notes to ourselves about what that is, but let's do our next example then.
About what is?
About how we do that.
Oh, we're going to do that. Yeah.
Like that.
You're good. We're on the right track. All right, in the parentheses, we have a squared, b to the third power, and on the outside we have a 4 to the power of 4.
All right, so let's test that idea. Think about if we can use the same idea that we would multiply. I think what I would say is we multiply the inside by the outside. So let's test that.
So let's think, how many a's are there? 2. So let's do a times a. How many b's? 3. 1, 2, 3. But we're going to repeat that how many times? 4 times. So I'm going to do it again. A times A, B times B times B. That's 2 times. I need 4. Now I have it 3 times. I'm going to try and squish it in this last time.
If you have to go down to another line, that's fine.
I know, but I went down to another line in all my classes, and this is the first one I got it in one line. I'm very excited about it. So it's A times A times B times B times B times A times A times B times B times B times A times A times B times B times B times B times A times A times B times C times C. So how many A's do there end up being? 8, because it goes 2, 4, 6, 8. How many B's are there? 12, because we're taking 3. How many times do we have 3 B's? 4 times. So 3 times 4, 12. Can we combine our A's and B's? Nope, so we're done. Well, we're going to do it with a little bit more complicated. Yep, we're going to do 2 more problems. It's going to be quick. We're not going to write it out like this. We're going to use the rule now so that we don't have to write it out. Okay, so our rule is called the power of a power. And power of a power will look like inside the parentheses, we have like an A to the B power. And then we have another power on the outside like X. Or, this is actually another rule at the same time, a power of a product. So again, what does a product tell us? An answer of a multiplication. So on the inside of the parentheses, we're going to have two things. So we might have a to the b power, and then maybe m to the p power, with a variable on the outside, or an exponent on the outside. So we do kind of the same rule with both of these. Can anyone remember how could we have just jumped from the problem in number 4 to the answer? Yeah, you multiply. You did that 4 times the 2 and then 4 times the 3. So when we see this, when we have those parentheses with an exponent on the inside and an exponent on the outside, a power of a power, we are going to multiply each of the inside exponents we multiply each, and I underlined that word each because that's really important. And we multiply it by the outside exponent. We have two pretty quick examples that we're going to do after that once people copy this down. It takes up about 4 lines, so if you can fit them in, one here and one here. If you have 4 lines, you should be able to fit it in if you write kind of small. If you're out of space, that's okay, just go to the next page. Not a big deal. Alright, so number 5. We're going to have the quantity, so quantity again means those parentheses, -6 p to the 3rd power t. And we're going to take that whole thing to the 2nd power. So what parts do we need to multiply? The 2 and the 3. What else? Close. You're right. What's the exponent of the t? 1. If we don't see an exponent, we ask ourselves how many t's are there? Sorry. There is 1 t. That's okay. So we put a 1 there. How many -6's are there? 1. So we're going to take this outside 2, and we're going to multiply it by each of the inside. And it kind of reminds us of what property? It's similar to distributive, but distributive is a little different. We use it in a different way. So this is the power of power. So we're going to take -6. And what is 1 times 2? 2. P to the 3 times 2. 6. T to the 1 times 2. 2. This one's a little different because we have that -6. What do we call those numbers in front of variables? Close. What? Coefficient. What's a constant again? A number without a variable. A number by itself. Yep. So this one's a coefficient. When we have a coefficient, we actually have to evaluate it. We have to find the answer. So when we see negative 6 to the second power, what does that mean? Good. Negative 6 times negative 6. And what is negative 6 times negative 6? 36. So our final answer is going to be 36. P to the 6th power. T to the 2nd power. All right, we have one more. I'm going to give you a little bit of time to try this one on your own first. And then we'll do it together. So for number 6, we're going to have the quantity of 5 m to the 6th power p x to the 3rd power. And it's all taken to the 7th power. Power of 7. So if you want to try and work ahead, I'll give you about a minute to try and figure this one out. See if you can simplify. Try it on your own, or start thinking through it. So what's really great about this lesson is if you don't understand the rule, you can always go back to writing it all out, right? How many times would you write 5m to the 6th p x to the 3rd? How many times are we taking this whole inside? 7 times. So if you wanted to write out, you could write out 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd, 5m to the 6th p x to the 3rd. And then you could get that all out, and how many m's is really m to the 6th? 6, and how many x's is x to the 3rd? 3. So you could write out 5 times m times m times m times m times m times m times p times x times x times x times 5 times m times m times m times m times m times p times x times x times x times 5 times m times m times m times m times m times m times x times x times 7 times. If you want to. But instead, we get to use our properties. We get to use our rules. And our rules say that we can take the 7 and do what with it? Multiply it by what? The inside. If I don't see an exponent on the inside, what is that exponent? 1. So I'm going to put a 1 with the 5. Is there anything else that doesn't have an exponent? P. So what is 7 times 1? 7. 7 times 6. 7 times 1. And 3 times 7. 21. So we're taking that 7 and we're giving it to each part. Now we're not quite finished yet. Which part do we still need to simplify? The 5 to the power of 7. So I'm going to show you on decimals, just to make sure we all know how to use the calculator. Because this I don't expect you to be able to do without a calculator. It's an insane number. Okay, in decimals, you have two options. You can either type 5 times 5 7 times. 1, 2, 3, 4, 5, 6, 7. That was pretty easy to keep track of, but if we had like 5 to the 14th power, you wouldn't want to count that. So in your calculator, to get an exponent, we use this a to the b power. So we're going to do 5, and then I'm going to hit this button, a to the b, and then 7. So 5 to the 7th power is 78,125. And then we still have the m to the 42nd power, p to the 7th power, x to the 21st power. Alright, we are done with notes for today. What do you mean, thank God? It wasn't that bad.